Hi everyone. So we're here to have a project-based learning and hands-on learning with Pythagorean theory or Pythagoras theory. You can call it either way. So for this project, we're gonna need cardboard. Okay, you're seeing cardboard. We need rulers. We're gonna need water. This is water. We're gonna need. You can use disposable plates as well if you don't want to use a cardboard. We're gonna use straw. We need scissors. We're gonna use scissors as well. We're gonna use rulers, and we're gonna use bins. Okay, so these are bins, and we're gonna use Legos. Legos, but I'm using this to represent Legos. So let's look at different representations of Pythagoras theorem using project-based learning. So first, you get your ruler. So we're gonna cut the angle which already cut here. So this is the right angle. So what the Pythagorean theorem is saying is telling you the two sides of the right triangle is equal to the opposite side. That's the side opposite to the side of the right triangle. So that means a square plus b square is equal to c square. So I'm going to put this as c square. Okay, so what that's saying to you is a square plus b square is equal to c square. So that means this side, which is a, and then plus the side b is equal to this side c square. So square of each side. Okay, so let's look at this using this project. Okay, so we have this triangle. Okay, and then this side of it, the a and b are called legs. Okay, and the c is the hypotenuse. That's the 5. So for now we're representing each legs. So leg a is 3, leg b is 4, and then the c, which is the hypotenuse, is 5. Okay, so let's get this. What you're gonna do, you're gonna use your ruler. You measure the side of the triangle, and then you're gonna get, once that is done, you cut out the triangle, and you're gonna cut out different papers. You can use cardboard or just regular papers. So you get different papers, and that way you can put them on the corresponding side of the triangle. So look at this, and then this is the other paper I'm putting here. Just a moment. All right, 1 second. All right, so then the other side is this. Okay, the other side is this. So what that is telling you is saying 4 square and 3 square is equal to 5 square. So let me write that real quick. 4 square is gonna be 4 times 4. Okay, that's what I've written here. 3 square is gonna be 3 times 3 equal 9. 4 times 4 is gonna give you 16. Okay, and then let's do the 5 square. 5 square is gonna be 5 times 5, which is gonna be 25. So what that is telling you is when you had this side, which is 9. Okay, so it's saying a plus, from what you can see here, a plus b square equals c square, which means 3 square, which is 9, plus 4 square, which is 16, equal 25. Let's look at this theory. This is true, this is correct. Okay, so I also did the square in smaller squares here. Okay, so we can count the squares together, and here we have 9 and here we have 16. Okay, that way we can make 25 square in this other sheet. So real quick, okay, so that way we can make 25 square to let you know that it's 25. So the a square, which is 3 square, b square will be equal to c square, which is 25. The other way to prove this theory, you can also prove this theory this way. First of all, you measure the side of the angle, which I already measured. So you're gonna take each side, then you After you measure the angles, now you take each papers. Okay, these are different papers. Okay, it could be blank paper. Now when this is the A square, when I place the A on the C, and this is the C, you have A, that's your C. And then when I place the A on the C, okay, and I place the B on it, it's going to fit in there, right? It's going to fit. Okay, so you can see this is so perfect that the A square and plus B square, you know, putting them now in measurement using the papers is going to give you C square. Okay, all right, so let's go into the other representation of Pythagoras theorem using beans. Okay, so this way we can use beans on this side and with straw as well, beans and straw. So we already said 1 2 3 3. Okay, so this side will be 9 beans because we said 3 of it, 9. Okay, and then this side will be 16. So we're going to count 16 beans. I'm counting your the 16 beans. And this is 16. So what that is telling us is when we put both sides together, okay, this is the C side. When we put the A and the B side together, that's going to give us 25 for the C side. Okay, so when you count those beans here, it's just exactly 25 for the C side using the first problem and real world question we have. Okay, the same also goes with using water. Okay, so I'm going to remove the beans right now. You can also use water as well. Okay, however you want to do it. You can pour water on different side. Okay, so when you have water here, you have water here. Okay, so what that means is when you remove the you can pour more water. So when we remove the straw now from the two sides, you can see, okay, so they're going to flow to the C side, residing in the C side. Okay, so that's a 3D representation letting you know that it's flow to the C. So the A and B, which I already removed, is equal to the C. Okay,